Okay, good morning, good afternoon, and good evening to everyone. Welcome back to our lesson in BS 140, BEC 140, BSB 140. I'm solving worksheet 5. In the previous video, I solved the same worksheet 5, but for the first 4 questions, that was on linear functions. So in this video, I'm going to solve question 5 to 8. In this video, I'll be solving question 5 to 8. Please take note that we're talking about BS, those in BF, BEC or BSP 140 course. That's business mathematics. This is the business mathematics, and this is a worksheet 5 at the Copperbelt University. Worksheet 5 at the Copperbelt University, and we'll be looking at question 5 to 8 of this worksheet. Now, we'll just be solving with the knowledge and understanding that we already know the applications of linear functions. So these questions are coming from the applications of linear functions, where we have to understand that linear functions can be used. Linear function can be used to explain the concept of the demand, the supply, the cost, revenue, and so forth. I think we talked about that theoretically as we were learning the demand function, the supply functions. So we'll kick starting as we go to solve question number 1. Question number 1. This one is question number 1, but we know that it is coming from worksheet 5, which is question number 5. So here we go. So let's look at the question. The question says, and the equation of the demand function is given by Q equals to 64 minus 4P, where Q is the number of helicopter flights demanded daily, and P is the price per flight in hundreds of kwachas. That's what it means there. So in hundreds of kwachas. The question number comes in to say, plot the demand function with Q on the vertical axis. So remember in our theory class of demand function and supply function, we mentioned that when it comes to the demand function, this one is a function which explains a negative relationship which exists between the price and the quantity. So this demand function can be in the form of P equals to A minus BQ, or it can be in the form of Q equals to, let's say, A minus BQ. So in a situation whereby P is the subject, in a situation whereby we have P as the subject, and in a situation whereby we have Q as the subject, the difference between these two is that this function, which is a demand function, is in the form of f of q, and this one is in the form of f of p. Sorry, this is supposed to be p. Okay, so this is a p there. So this is in the form of f of p. So now, every time when it comes to the sketch of these functions, remember you can even see that the slope is negative. The slope is negative. Negative b here is the slope. So if I look at this negative b here is explaining the changes happening in p over the changes happening in the q. This is our slope. Here, what will be the slope? The slope is this negative capital letter B, because the comparison is q and p. So the comparison in this case will be the change in q over the change in p. So this is where I was even emphasizing on to say, when you see the two functions given to you, you should be able to spot out how is the function written. The function can be in the form of f of q, or the function can be in the form of f of p. That's how it is. So if these are the two cases, it means if I'm explaining the slope in the form of f of q, the slope of f of q, which is negative b, will be explaining the changes in p over the changes in q. This means for every unit increase in q, p will decrease by b units. But in this case, for every unit increase in P, Q will decrease by B units. That's what it means. That's what we have there. So for this one, we're simply saying for every unit increase in Q, P decreases by B units. But huku, we are simply saying for every unit increase in P, for every unit increase in P, then we will have Q, which will decrease by B units. That's what it means. So the slope can be explained in that manner. So look at your demand function which has been given. Is it in the form of f of q or is it in the form of f of p? And when it comes to the sketch, remember this is a negative slope. So it means if I have the y-axis and the x-axis in that manner, we're talking about the line which will be sketched will be in that manner, where this will be the x-axis and the y-axis. So it means the y-axis in this case will be, in the case of the price axis, this is a 0 there. Let me just try to see if I can sketch it nice. Okay, so we have the y-axis, which will be represented by the price, and the x-axis will be represented by the quantity. So since this is a negative slope, you are expecting the curve to move in that direction. So if this is my quantity axis and this is my price axis, the demand function, which is P equals to A minus BQ, will have the vertical axis to have the price and the horizontal axis to have the quantity. In most cases, if the function is in the form of f of q, then we are always encouraged to take the vertical axis to have the price and the horizontal axis to have the quantity in most cases. So where it's going to cut the price axis here, it's a price intercept. It is this value of A there. The value of price when Q is 0. So when you press Q to be 0, you have the price intercept to be A. You have the quantity intercept there, where you press P with 0, and so for Q, that will be the value for quantity intercept. But when it comes to this case side over, where the function is in the form of f of p, remember it's still the same slanting, but this side it will be the quantity axis and the horizontal will be the price axis. So if I have q to be equals to a minus bq, bp, sorry. So if we have q to be equals to a minus bp, this is in the form of f of p. So every time we have a function in the form of f of p, it is encouraged that you take the vertical axis to have the quantity and the horizontal axis to have the price. Which means that this particular point, it will be the quantity intercept, which capital letter A there, and this will come and be the price intercept. So number, this is the arrangement of whatever we have there. Now let's go back to our question. Our question says the equation of the function, the demand function, is given by Q equals to 64 minus 4P, where Q is the number of helicopters flights and P is the price per flight in hundreds of watts. So we are being told to plot the demand function with Q on the vertical axis. It makes sense because this is in the form of what? This is in the form of f of P. Q is as a subject. So this is a straight line, and we know that when it comes to a straight line, in the previous example we talked about just if you want to sketch a straight line, you can just come up with 2 points. So what is our demand function? Our demand function in the question is, so the demand function is So we have our demand function in this case given as Q is equal to 64 minus, is it 4p? That was the demand function which was given in the question. We have 64 minus 4p, and this is a straight line here. This is a straight line when you will sketch this. So when we want to sketch a straight line, what are we supposed to do? We can use the point of the intercepts. So what are we going to find? We're just going to find the intercepts. Number one, we can find the quantity intercept. The quantity intercept point. This is happening at the point when P, Q is equal to 0, a certain value of Q. So quantity intercept is happening when our price is 0. So we solve for what? For Q. So in the equation where Q is equal to 64 minus 4p. So after the P we put a 0 and we solve for Q. So this Q will be equal to 64 minus 4 multiplied by 0. Automatically this becomes 0 and the value of the quantity intercept becomes a 64. So this will be 0,64 as our coordinates on the quantity intercept. Then we can do the same for the price intercept. The price intercept is happening when P, Q occurs at the point. Since I'm looking for the price intercept, the one which is a 0 now is the value of Q. We are solving for P. So in the same equation where Q is equal to 64 minus 4p, after the Q we put a 0 and also for P. So Q is equal to 0 to be equal to 64 minus 4p. Solving the value of P there, the negative 4 can go to the other side, becomes positive 4p to be equals to 64 over 4 over 4, and the value of P in this case, what are we going to have? 4 into 64, I think that's 16. This is the price intercept. It means I am happy this is happening at 16,0. 16 is the price value and 0 is the quantity value. So now, how will the sketch look like? So with this particular point, you are able now to sketch your graph, the y-axis and the x-axis. Remember, since our equation is in the form of f of p, q is the subject, we are being told to take the y-axis or the vertical axis to be the quantity axis, and the x-axis will be the price. And this is a straight line with a negative slope. A negative slope means it will be slanting in that direction. So up, where it's going to cross from is at price intercept, it is at 16,0. Here where it is going to cross from, it is the quantity intercept, it is at what? 0,64. That's how your sketch will be. And you can be able to label, say this is Q equals to 64 minus 4p. Remember, always label your graph. Always label your graph. So this is just a sketch you can use, since we are trying to just sketch. But if you are trying to sketch this accurate, it means you have by default you are supposed to be able to create your table of values. So the table of values you are going to create will be something where you've already created your intercepts, the values of Q and the values of P. You've already created your intercepts. You have a point where Q is equal to 0 and you have the point where P is equal to 0. So I don't know how many intervals you are going to use. Remember, when Q is equal to 0, the value of price is 16. And when P is equal to 0, the value of quantity is equal to 64. So it's up to you to use whatever scale, at least your sketch of values. The interval of values should be from 0 less than or equal to Q, and this Q should be less than or equal to 16. This should be the intervals of quantity you are going to use. I don't know how many, actually this is 64, sorry. I don't know how many intervals you're going to use. Maybe it should be 5, 10, 15, 20. As long as these values are from 0 to 64, it is accommodated. And for the price, you would use, obviously, since the last final price is 16, which is the highest price. So it means our values we can use is the interval p less than or equal to 16. So maybe if you are using scale of 4 units, 4, 10, 8, 12, 16 and so forth, you can be able to use a scale of 4 units. And then you'll be able to break it down in that manner. So that's what we mean by this situation. So you can be able to bring it down to say, okay, from this situation, maybe I can use the scale from 16 to 0, I can be decreasing it by 4. 16 minus 4, maybe I can have a 12 minus 4, this is 8, minus 4, this is a 4, until I get a 0. And then you'll be able to put in the values of Q. What are you using? The same equation. Q is equal to 64 minus 4p. So it means I'll be inserting the values at p to find the value of Q. That's what you'll be doing. So when p is 12, you insert there and find the value of Q. So it will be more like you'll be finding Q equals to 64 minus 4 multiplied by 12. This is in a situation when QP is what? Is 12. So it will be 4 multiplied by 12. The answer subtracts from 64. Obviously, you're going to have a 16 somewhere there. You do the same when it is 8. You insert it in there. 8 times 4, the answer subtract from 64. So you are going to have values like, you have a 32 somewhere there. If you insert a 4 there, 4 times 4, you subtract from 64. You are going to have 64 minus 16. You are going to have a 48 there. So this is how your scale of values are going to use. If you want to be accurate, you can be able to use those values. If it is just something like a rough sketch, your idea is that this graph, it is a negative slope, it is going to slant in that direction. It is crossing in the price axis at 16, this is the price intercept. It is crossing the quantity axis at 64, this is the quantity intercept. So the rest of the values are just in between here. So if you look at this graph here, which is simply saying 0, 16,0 here to be the price, or maybe we're talking about this is what? 0,64. This is the point. We can continue to 4, what? When you bump this curve at 4, the value of the quantity this side will be what? Will be 48. If we continue increasing the prices, we can see that the quantity will be decreasing because of the negative relationship which exists. So when price is 4, you can see that when I bump into this curve, I'm going to have the quantity to be 48. When price is 8, when price is 8, if I bump into this curve, I'm going to have the quantity value to be 32 at that particular point. When price is 12, when I bump into that curve, I'm going to have another particular value this side, which is what? 16. So you can see that the higher the price value, the less the demand function we are going to be having. That's the concept. So in this situation, a sketch is not difficult. The sketching, you just use the same value. So a clean one, we're just simply saying the y-axis and the x-axis. The y-axis is the quantity axis, and the x-axis will be the price axis. And this is a negative slope, which is going to move in that direction. Here it is at 16, and here it is at 64. As simple as that. That's your plotting. And the equation is Q is equals to 64 minus 4p. So the straight line will move in that direction. As simple as that. So that's the first part. So the first part says can you plot? We wanted a plot, the demand function with Q on the vertical axis, and we have achieved our first objective there. B, it says what is the change in demand Q when price increases by 1 unit? What does this explain? This is just explaining the slope. And if you can take note, we just mentioned here that if we talk about the slope, when Q is equal to A minus 3B, the slope, this negative B, is change in Q over change in P. That's what you said. And the verbal description means every unit increase in price, our quantity will decrease by B. This side, if this is a function we have, it means every unit in Q, our price will decrease by B. So look at your functions. Is it f of P or f of Q? That's your M. So in that direction, what do? We solve for the changes there. I think I can even use the same part. Maybe I can just delete this part so that you can be able to see what is happening there. So what are we simply saying here? We are talking about the change in Q. So since Q is equal to 64 minus 4P, it means this negative 4 is the slope. Negative 4 can be calculated as, so negative 4 can be calculated as, since it's a slope, negative 4 will just be equal to change in Q over the change in P. Change means the change which has existed for a certain change in price. So here we are simply saying if price increases by 1 unit, what is going to happen to the increase in the what? In the changes in the what? In the Q. So we are simply saying negative 4 is equal to the change in Q which we are looking for, over the change in P has increased by 1. So this is positive 1. Increment means positive 1. So we'll solve for change in Q. So this implies that the change in Q will be equals to, this is over 1, cross multiply from there, we will have a negative 4 as our solution. What's this verbal description here? It's coming out to be negative. This means for every unit increase in price, quantity decreases by 4 units. That's what this means. It's coming out to be negative 4. It means if price increases by 1, the quantity of demand will decrease by 4. That's why we have this guy. As simple as that. So this is the information. So we have plotted, we have found the change in demand for every unit increase in price. Now the other question comes in to say, what is the demand when P is equal to 0? We've already even found for this. This is the what? The quantity intercept. So if the equation is Q equal to 64 minus 4P, we are looking at when P is equal to 0. We put in P there to be 0. And what will be the demand? So we can delete this part again so that we can still use this, visibly seeing the question as we are solving. So you can be pausing and understanding the concept. This is a video. So what are we having here? We are solving C. We are solving C. So what am I having? We have the quantity, the demand function will be given by Q equals to 64 minus 4P. That's our quantity. Okay, let me continue this deletion. Okay, so if this is the case, what am I going to have? We want to solve when p is equal to 0. This is what we just solved for the quantity intercept. So this will be 64, 4 multiplied by 0. And this will be q equals to 64 minus 0, which is equals to 64. This is the value of q. As simple as that, without any issues there. So verbally, we are simply saying, since q is the number of flights and p is the prices for those flights, so in verbal description here, we are simply saying if p is equal to 0 and we have quantity equals to 64, it means if flights are free, demand is 64 flights per day. So this means verbal description of this, since the instruction is, we can also be indicating some verbal description there. We can also be indicating some verbal description there. So what does this mean? We are simply saying if the flights, since q is representing the flights, if the flights are free, you are not paying anything for the flights. Flights, sorry. F-R-L-R. If the flights are free, then the quantity of demand is 64 flights. The demand will be 64. So the demand will be 64. Let me just say the demand here will be 64 units. It's 64 flights. So p is equal to 0. We have 64 to be equal to the quantity. So it means if the flights are free, because price is 0, it means it's free, then the demand will be equal to 64 flights. But what about in a situation whereby we are looking for q when q is equal to p when q is equal to 0? So what are we going to have? If q is equal to 64 minus 4p, we are solving for price. After the q we put in a 0, this will be 64 minus 4p. That going to go to the other side becomes positive 4p to be equal to 64 over 4 over 4. This goes and the value of p becomes 16. Verbal description with this case, what does it mean? Verbal description in this case, what does it mean? Remember, we said let's go back to your question. We said q is the number of helicopters and p is the price per flight, and this price is what? Is in hundreds, isn't it? Hundreds of kwacha. So it means hundreds of kwacha there. When we say hundreds of kwacha, what is the price which we have there? We are trying to say if p is equal to 16, it means the actual price we're talking about here implies that we're talking about multiplying this by 100 will have a 1600 kwacha per flight. This is what we mean. We'll have 1600 kwacha per flight because all the prices there are calculated in hundreds of kwachas. So it means every p will multiply it by hundreds. That's what it means. So number, the question is, how do we verbally describe the meaning of all this? How do we verbally describe the meaning of all this? So we are simply saying that if this means if the price of the flight is at 1600 kwacha, then there will be no demand. This means there will be no demand. That's what it means. So if we set the price to be 1600 per flight, we are going to experience that there will be no demand. There will be no demands of the flights. In this situation. So this is how you'll be able to solve your question number 5. So application of linear functions. You sketch, you plot from the concept of straight lines, then the change is explained from the concept of the slope. You demand when p is equals to 0 the same equation, and you'll be able to calculate. And then verbally, that's what we have there. I think we've explained verbally of each case, B, C, and D. As simple as that. Now let's go to the second question, which is this one. This is another simple question which we have to understand there. This one says the equation of the demand function is given by P equals to 65. That's the equation of the demand function, where P is the price of bread per loaf in Zambian kwacha. What is the slope of this demand function? And describe what this means. What is the slope of this demand function? And describe what this means. So number 1, what is the demand function given? This is a very nice question, and you have to be careful in answering. It's a very nice question. So the demand function given here is just P equals to 65. And when you look at this, because you're trying to relate P and Q and you can't see Q, then now recall something here. We have to recall something, right? These are linear functions. Y is equals to mx plus c. If this is the case, we said that there are 3 things involved of the gradient when it comes to y equals to mx plus c. I'm going to have m can have the gradient to be this, it means my m is positive. If the line is slanting in this direction is sketched, it means my gradient m is negative. If the line is vertical, it means my gradient m is undefined. This is what we said in the previous video. But if the line is horizontal, it means my gradient m is equal to 0. So now, if you look at this very carefully, what happens? So for the 2 first cases, by default, our equation, this one, will be visibly seen. We can be able to see visibly nicely the standard form of the equation. That's what you said when it comes to two cases. For example, maybe you have y is equals to negative 2x plus 3. What is it? Sorry, this is a positive gradient. So for something which is a positive gradient, which is going to make my line to be slanting in this direction, maybe you are going to have y to be equals to positive 2x plus 3. The gradient here is positive 2. Any line which is slanting this direction needs to have a gradient to be negative. Maybe you are going to have y to be equals to negative 2x plus 3. The gradient here is negative. But something which is undefined, we said that by default, what is going to happen with an equation which is just in the form of x maybe equals to 3. This will be just a vertical line passing at 3 on the x-axis. It means the gradient is what? Undefined. This is what you said. For the gradient to be m equal to 0, if the gradient is 0, it means we will just have a horizontal line. The only possible equation we are going to have is y equal to c. Maybe, let's say a certain number, maybe 4. Y equal to 4. Or maybe y equals to 3. This is a horizontal line passing through at 4 on the y-axis. So these are the 4 cases. So every time in the equation I just see the variable x, it means my line will be vertical because it is cutting the x-axis. Every time I just see the variable y, I am seeing that my line is horizontal because it is just cutting the y-axis, and the gradient will be 0. So just from the same case in, I won't see the x because it's gradient times x, making this x to disappear. So if a gradient is 0, the x will disappear to be 0 times x. That is why we have the y equal to what? C. Now we are trying to relate this in the form of the demand function. And the demand function is in the form of P to be equals to A minus BQ. This is what we said. And in this case, we're looking at 64 there. 65. So in this case, let me just write it from there. Demand function. The demand function here is P equals to 65. So we want to relate this in the concept of P equals to A minus B cubed, because this is the standard form which we know. But if this is my demand function comparing to this, what are we seeing? It means that this can still be written as, with including the Q, this is just as good as 0Q plus 65. As simple as that. So if I look at P equal to 65, this is just the same as writing it as P equal to 0 plus 0Q plus 65, because I'm trying to bring in the concept of the relationship which exists between P and Q. And there is a 0 there. There is a 0 there. So what does this mean if there's a 0 there? It means that the change in P over the change in Q will by default be equal to what? 0. So if it is equal to 0, every changes in the Q will cause the P to change nothing. That's what this means. So it means every change in Q causes, how do you spell causes? Every change in Q causes a 0 change in the price. That's what this means. So this means every change in Q causes a 0 change in price. That's what that means. So the price never changes regardless of the quantity of demand. So here means the price will never change. So in other terms, we can simply say the price never changes. Never changes regardless of the price. The quantity of demand. That's what we are simply saying. That is why we have the slope here. The slope in the function P equals to 65 is just 0. This is the meaning of why we have the slope to be equal to 0. As simple as that. And then if we would want to plot this, in a situation whereby we want to plot this, how do you plot it? This is just a horizontal line passing through on 65 on the y-axis. So plotting this, let me just delete. Let me delete somewhere here. So if I want to plot this, regardless of the quantities, so this is my y-axis and the x-axis. This is quantity and this is price. So this will just be a horizontal line. This will be at 65 somewhere there. It will just be a horizontal line there. And this will be P equals to 65. So when quantity is changing, price is just stagnant. For every quantity, the price is just still the same, 65 kwacha. That's what it means. So what we mean here is that for every, regardless of the quantity of demand, the price remains the same. That's what we mean. So the sketch will just be a horizontal line passing through at 65 on the y-axis, and you are done without any issues. Yeah. Because the slope in this case is equal to 0, and this is a change in P over the change in Q. This is a 0 slope. As simple as that. Let's go to question number 3. Let's go to question number 3. So question number 3 says, given that the supply function, now we're looking at the supply function. If you look at this, it's just the same question which we talked about in question number 5, but question number 5 was demand and this one is the supply function. So given that the supply function is P equals to 500 plus 2Q, where P is the price of a bottle of munkoyo in Zambian kwacha. Q is the number of liters supplied. Number 1, graph the supply function. What is the meaning of the value of the vertical intercept? I'm sure this is still simple as straightforward, what we did last time. So, graphing this, all we need to have is what? Number 1, yes. Number 1, P is equal to 500 plus 2Q. This is the supply function. 500 plus 2Q. So sketching this, we will just need to find, obviously, possible two values. Since this is a straight line, we know it's a straight line. So this is Q and this is P. So we'll look at the value when Q is 0 and the values when P is 0. So when P is equal to 0, or maybe let's say when Q is equal to 0, obviously we're talking about the price intercept being formed here. The price intercept is found when your quantity is equal to 0. The quantity intercept is found when price is equal to 0. So when quantity is equal to 0, we'll have the price intercept. So in the function there, we're going to have P to be equals to 500 plus 2 multiplied by 0. This will be equals to a 500. So this is our price intercept there. So the price intercept, price intercept is found at Q, P, P, which is equal to 0, 500. This is the price intercept. And then the other concept is when P what is happening when P is equal to 0. So from the same function, P equals to 500 plus 2Q. When P is equal to 0, this is 0, this is 500 plus 2Q. So for Q, 500 can go the other side, become negative 500 to be equals to 2Q over 2 over 2. So that we have the value of Q to be equal to negative 250 units. This is the quantity intercept. So if this is my quantity intercept, I'm going to have a negative 250 there. That's what we have. So if I sketch this, it's a positive gradient. So if this is my y-axis and this is my x-axis, I'm looking at this becoming my 0, and this is my price axis, and this is my quantity axis. We are saying that if let's say 0, 500 can be somewhere here, this is 500 where the price is. So there is a point here where the curve is going to pass through from the coordinates which you have here, 0, 500. Negative 250, 0, it means negative 250 on the quantity axis. Quantity axis, obviously negative none can be this side. In the quantity, in negative axis. So maybe if negative 250 is somewhere there. So we're talking about somewhere at this particular point. And this is a straight line. So from here, it is coming. And it passes there. And it continues in that same direction. Now, here we're just concerned with something which makes sense. I've used this to be dotted because this is in real life situation. So I'm just trying to use it to come up with my accurate sketch or my correct sketch, which can help me draw my straight line. This is the negative axis. I can't have negative quantities for negative prices. So that is why most of the cases in such situations we always focus on the positive accesses. But mathematically we can be able to draw this, but economically this is not meaningful. This particular point is not meaningful. That is why our sketch will always start from the price intercept, goes in that direction, since it's a positive slope. And the function, don't forget to label your graph. 500 plus 2q. As simple as that. And you've sketched. You know the meaning of the intercept. At price intercept, if price is 500 and quantity is 0, it means at this particular price, this is the price where we are going to start supplying the quantities at. That's what it means. So if we have 0 liters of munkoyo supplied, the price must be 500 kwacha to enter market. So that's the minimum supply we can have there. So in actual situation, what we are simply saying here is we are simply saying that the meaning of the vertical intercept at the vertical intercept we are simply saying that even if 0 liters is supplied, even if nothing is supplied, the price must be 500 kwacha to enter market. You can't enter market with nothing. At least you have to enter the market with the 500 kwacha to enter market. In actual sense, what we are trying to say here is this is the minimum supply price. This is what we mean. This is the minimum supply price. Anything less than that supply will not happen to you. That's what the vertical intercept means. We are okay? So we've answered the first part. The second part says find the value of Q when price is equal to 600 kwacha. Sure, that's very much simple. Finding the value of Q when price is equal to 600 kwacha, just using the same equation, 500 plus 2Q. You are looking for the value of the value of Q when this P is equal to 600 kwacha. So you replace 600 to be equals to 500 plus 2Q. So this can go to the other side, become 600 minus 500 to be equals to 2Q. So this is over 2 over 2. So that the value of Q which you are going to have will be equals to 600 minus 500, that's 100. 100 divided by 2, we are going to have 50 units. This is what we are going to have at the second part, B. That's very much easy. So it means, what does this mean verbally? This is an indication that when we have 50 liters of munkoyo, this will be sold at 600 kwacha per liter. That's what we mean, to be supplied at 600 kwacha per liter. That's what we are going to have. So 50 units will be supplied to you at 600 kwacha per liter. That's what it means there. So the higher the liters, the higher the price. That's what we mean there. So 600 kwacha produces about 50 liters. This is what it means. So this means 600 kwacha produces 50 liters, because these are liters. Then you do the same at part C. Sure, this can be, you can be able to solve this even on your own. You can be able to solve C, which says find the value of P when Q is equal to 20 quarts. So upper the Q, you put in 20 quarts. I'm leaving that one for you. Upper the Q, you put in 20 quarts, and then solve for price. I think you can be able to send in your answer for C. Send in your answer for C. That's very simple. I can go to question number D and E. Now, question number D says express the supply function in the form of Q equals to F of P. Remember, we said that the function can be in the form of F of Q, the function can be in the form of F of P. So express the supply function in the form of Q equals to F of P. This is what we're trying to do. This is E. Express supply function in the form Q to be equals to F of P. So now what is given, what we have been given is P equals to 500 plus 2Q. This function is in the form of F of Q. What we are looking for is the form of F of P. It means make Q the subject. So 2 goes to the other side, becomes, or maybe, yeah, we can make, this is P, 5 goes to the other side, becomes negative 500 to be equals to 2Q over 2 over 2 over 2, so that the value of Q becomes 1 over 2, here it's a 1 here, and this is a variable P, minus 500 divided by 2, this is just as good as 250. This is the function we're going to have when Q is the subject, and this function is in the form of F of what? F of P. This is what we have been taught there. So from this case, it says express the supply function in form of, you've done. That's a mark. Number E says determine the increase in the number of liters supplied for each unit. This talks about the what? This is just a definition of the what? Of the slope. This is just a slope. The increase in the number of liters supplied for each number of liters is Q. For each unit increase in what? In price. Each unit increase in price, it means this information is obtained from the function which is in F of P. Unit increase in price, what will be the change in Q? It means it's in the form of F of P. So from the demand function given here, the slope here is 1 over 2. And this 1 over 2 is happening from change in P over change in Q. Remember, if it was in the function P equals to 500 minus what? Minus 2Q. I mean plus 2Q. The slope here is positive 2 is equal to change in Q over change in P. Know the difference. If it is in the form of F of P, sorry. This is change in P. So know the difference. If it is in the form of F of P, Q is the subject. This will be change in Q over change in P. Here P is the subject. The slope will be change in P over change in Q. Know the difference. So that the slope here becomes, what will be the slope here? The slope here becomes 1 over 2. Change in Q over change in P. Here the slope becomes 2. Change in P over change in Q. You can either use the 2, if still they have the same answers. So we are looking at what is, let's go back to the question. What is, determine the increase in the number of liters. The number of liters means Q for each unit increase in price. So price has increased by 1. What will be the change in quantity? Any of these two will work. So change in P is equal to 1. This is what we have been taught. What is the change in Q? If you use this one, we have 1 over 2 to be equal to, you are looking for the change in quantity over 1, since the price has increased by 1. If you use this one, you are talking about 2 to be equal to, price has increased by 1, you are looking for the change in what? In quantity. That's what it means. So it means the change in quantity here will be equals to, this time that will be 2 change in quantity multiplied by 1 over 2 over 2. So that change in quantity will be equals to 1 over 2. And you're done. If you still use this equation, this will be over 1 cross multiply 2 change in Q to be equals to a 1 over 2 over 2, and the change in Q will be equals to a 1 over 2. As simple as that. So it means if price increases by 1, the quantity of supply will increase by half. That's what it means there. As simple as that, and we are done. Let's go to the last question. Let's go to the last question. The last question says the equation of the supply function is given by Q equals to 1200, where Q is the number of hospital dinners supplied daily. What is the slope of this supply function? What is the slope of this supply function? This is another situation where we talk about understanding the slope based on the function which has been given to you. So, what is the slope of this supply function? So, how do we define the slope here? This is the quantity value, and we know that the supply function, the general supply function, should be in the form of P equals to A minus BQ. This should be the slope attached to the Q. But we don't see A, we don't see B, we don't see P. It means what is happening here? We're trying to relate it to be what? Now look at, recall something here. We said that if y is equals to mx plus c is the equation of the line, then anything in the form of y equal to c has the slope m to be equal to what? 0. Anything in the form of x equal to c has the slope m to be equal to what? Undefined. This is what you are going to relate here. So p is taken up to be y and x taken up to be q. So the function given in this case is q to be equal to Shinga to be equal to 1200. If you are to sketch this, how is it going to be? So sketching this, it means if this is my y-axis and this is my x-axis, we're talking about, if this is my y-axis and this is my x-axis, we're talking about the line which is going to be drawn will be a vertical line passing through at 1200 on the x-axis. So we're going to have a vertical line passing through at 1200 on the x-axis. This is 0 because this will be the quantity axis and this will be the price axis. So it's a vertical line passing through at 1200 on the quantity axis, and this is Q equals to 1200. This implies gradient M is equal to what? Undefined, because this is a vertical line. It's in the form of x equal to c, which is Q equal to c because x-axis is taken by the quantity. So the slope is undefined. This is the interpretation we're going to have. We can't define the slope in this case. So here Q is constant, 1200 is the same. So what are we simply saying? For this slope to be undefined, we are saying that Q is constant. Q we are seeing that Q is constant, and it being constant, but P varies. So for every change in price, quantity remains the same, 1,200. So if we think so for every change in prices, you can see there will be various prices which will be changing. When they bump the curve, they will still find the same value of quantity. So Q is constant, but P will be changing. So for every change in price, Q remains the same. That's what we mean there. So Q remains the same. That's the concept. So there will be no change in the quantity of demand for any change in prices. So here there is no change in quantity of supply for any change in price. That's what it means. As simple as that. And plotting, I've just already plotted this. Plotting a vertical and a horizontal line should not stress you. Just draw a straight line passing throughout the quantity axis at 1,200. As simple as that, and you are done. So that's worksheet 5 for you. Plot the graph of the supply and describe the situation modeled by the equation. So the situation is, we've just described it, there is no change in quantity of supply for any change in price. Nothing. We've already described it. Otherwise, this is how you were supposed to solve your question 5 up to way to question 8 of worksheet 5. So in this situation, we will meet again next time in the next lesson, where we'll talk about maybe question 9 up to the rest of the questions. Thank you very much, and have a blessed weekend afternoon. Mr. Sot. Have a flavored weekend.